Aleksandrs Parfinovičs, co-founder,
Parfinovičs. Yes.
Parfinovičs.
It's very close.
Co-founder and CEO at Naco Technologies. He's going to master the keynote on transition to green hydrogen from fossil fuel to critical material problem. Can we fix things? He will let us know. Thank you very much.
Let's find out.
Let's find out.
Okay. So I represent the team called Naco Technologies, and we are focused on green hydrogen. In the last 3 years, we work with more than 20 customers. Some of them are the biggest in hydrogen. Customers like Siemens Energy, ThyssenKrupp, H-Tech, Hyundai, Toyota, Ballard, Cummins, so the biggest representatives. We also work with medium and smaller companies. So we know industry quite well. And what we see that unites these companies is that they really want to help to replace fossil fuels with hydrogen, but they all struggle with now the issue of critical materials. So let's see if we can fix it. But we start with hydrogen. So why it's important? It's actually the last missing key element of fossil-free economy. It allows to bring renewables to households, transport, and industry. But of course, we know the issue of green hydrogen is way too expensive. So nowadays, the price of production green hydrogen is around €5, but we want to have it at €1 to be comparable to gray hydrogen. And if we look what influenced the most this expensive green hydrogen nowadays, these are electrolyzers. Electrolyzer that produces green hydrogen. And it seems to be that it's quite difficult to achieve it because we need to significantly reduce cost of electrolyzers. We need to improve the longevity and efficiency. And the issue is inside of the electrolyzer stacks, there are two big problems. The first is corrosion of stack components because of the hydrogen being quite aggressive, smallest molecule, sneaking in, causing corrosion, short lifetimes, and high maintenance cost. The second big issue is high cost of catalytic materials. And when we talk about the catalytic materials, we talk about rare earths, materials not in wide availability on planet Earth. And when we look on kind of materials we are missing for the green hydrogen, nowadays we mostly mention iridium, which we can mine only a few tons. But if we look a bit further away, a few years in the future, we'll see that also platinum would be a critical material, nickel, and also the magnesium. So it means for us, it's not only PEM electrolyzer that will struggle from expensive catalytic materials, but also alkaline, solid oxide, IEM, basically all electrolyzers, and also fuel cells as well. So can we fix it? So as a humanity, we have two options. One, launch space mission, go to asteroids and other planets and look for these critical materials. Or we can look closer to our homes in new materials. And when I say we need to look for new materials, I would say even more important to find out the better way to apply these critical materials as catalysts. Why it's important? So nowadays, when we look on how the materials applied in form of coatings, we use methods like spraying or printing. It actually gives you quite thick coatings, a lot of materials wasted, but also homogeneity of spreading this material around the surface is pretty bad. So we have concentrations of this catalyst in certain areas, and we see that current concentrating in some spots of the surface damages the components. especially when we talk about the catalytic coated membranes. This is the first component that usually fails in the system. So what we propose, we need to have much better coatings. We need to use only few nanometers layers. To protect against corrosion, you need to have much more dense coatings. And also, when we talk about the catalytic materials, we literally need to use only few nanometers. Last year, we made research together with Heraus, German company, and find out that if we compare current catalytic coatings on cathodes, on electrodes, to what you actually can have if you decrease the amount of material, you can use 40 times less of catalytic materials. We use the platinum as our material, 40 times to give you the same performance or even better. And we also discovered that current technologies to apply catalytic materials struggle. So you basically can select either quite productive technique, but you waste a lot of materials, have all the issues, quality issues, or you take very precise, nano-sized techniques, but they are not scalable, they are very slow. So that's why the other methods quite expensive. So what we did, we increased quality technique that apply nanolayers. We increased the speed of this process, and now we have both of two worlds, quality and also productivity. So when you also speak about the techniques, you need to consider greeniness of technology. We don't want to build catalytic or green hydrogen based on dirty techniques. So really look into what kind of temperatures are used to produce catalytic materials, what kind of pollution. That all will lead to high energy cost, water consumption, and also pollution, which you will be tax credited later on. So I've mentioned smaller layers. This is the answer. Also, considering CO2, but you also can design new materials. This is what we do as well. We design some materials that avoid any expensive critical materials. What is very important, if you design new material, you need to be able quite quickly to produce it in thousands or even millions of pieces. Again, we think it's quite important. So, do I have still 3 minutes? Or only 7 minutes? Because it shows me that. Okay, yeah, 3 minutes. So we as a company, we actually support with modern coating technologies all electrolyzer types. So I've mentioned PEM, alkaline, solid oxide, IM, as well as fuel cells. And for them, last year we built the production line as well. So every recipe that we built together with our customers, we are capable to produce already in thousands of pieces in literally in few months' time. And for that, we also built the most compact and most productive inline available worldwide. So it's actually being only 8 meters long, it can produce 500,000 of components for our customers. So this is already here, and I would like to thank my team who made a tremendous job. And just to summarize what I've mentioned, so how to solve the critical material problem. First, you need to select the right application method, the right coating method. It should give you ability to coat nano-sized and also homogeneous coatings. Secondly, reduce catalytic coatings to nanolayers. This is the quick win that you can get. Look into the CO2 footprint of the technologies that you select. Otherwise, you will be surprised later on unpleasantly. And secondly, and the last, if you develop new type of coating, you need to ensure that you can quickly produce your components in thousands, so you don't need to wait years to actually use it in practice. So this is it. I'm Alex from Naco Technologies, and we empower green hydrogen revolution. Thank you.